Alright, welcome to this video. I'm going to talk to you today about friction and the different scenarios of friction. There's three basic situations that you need to know when dealing with friction. And I get a lot of questions about friction. These are some of the most detailed questions I get from people, and they want to know how do you identify different situations with friction, if it's at still, if it's at max force, or if it's moving. So I'm going to outline those scenarios here, and then I'm going to show you some examples. So what I have here first, this is a typical force of friction curve versus force applied curve. Okay, so on the y-axis I'm going to put the force of friction here, and on this x-axis I'm going to put force applied down here. Okay, and the way that friction works is that when an object isn't moving, let's say you have an object down here like this, let's say you have a force, as you apply a force to this object, okay, let's say that this is my object here and it's just sitting there. As I apply a force to this object, friction is going to oppose me in the other way. Okay, so here's my typical object. Let's say this is the force of gravity and this is the normal here. Okay, I'm going to have some force that I'm going to put on this force applied, and this is a rough surface. Okay, so there's friction here, and friction is going to oppose me. Okay, friction is going to oppose me. It's going to match my force in an equal and opposite direction. Friction's like that person that's always picking an argument, picking the opposite side of your argument. No matter what you say, that's friction. Okay? So here's the first situation. So I'm here, and I have some force applied like this, right? And I'm applying a force applied along this axis like this, okay? And then friction is going to actually match my force applied like this, okay? So for example, if I put a force on this box of, let's say, 10 newtons, let's say like this, friction is going to push back with 10 newtons. It just is. I mean, it's going to push back, okay? It will match your force until it can't, right? So we're still well within the range here. I mean, friction, you can think about it somewhat like someone bluffing in a game, right? Like in a poker game. Friction is going to keep bluffing you until it can't, basically, right? So 10 and 10. Okay, there it is. No problem, right? Fine. Then at some point, though, you're going to try to maybe push harder on that box, and you're going to say, well, let's see how tough friction is. Let's see how strong it really is. Is friction really that strong? What's the breaking point? And you may get to this graph, and you may say, well, okay, I'm going to push on this graph now. I'm going to push on this graph with 20 newtons. Let's see what friction can do. Friction is going to push back with 20 newtons because it's still capable of doing that. So again, think about poker players and people bluffing, okay? So at this point, I have my force applied. I'm just going to write the force applied in here. Force applied was 20 newtons, and the force of friction in this case was 20 newtons also. It's matching my force, right? So you may come back and be like, all right, tough guy, I'm going to put 30 newtons on you. Let's see what you can do now. Well, is friction still capable of doing that based on this graph? It is, right? So here's my graph. Alright, so I'm going to put 30 on you. I'm going to put 30 on you, friction. Let's see what you can do. Well, I'm going to put 30, and friction's going to match me at 30. Friction's still bluffing. It's not really a bluff. I mean, it's really opposing me, but I want you to think about it that way. So it's at 30 now, okay? Force of friction's at 30. So you're like, alright, friction, let's see what you got. I'm going to push you to your max here, okay? You may not know it's the max, but we're gonna go ahead and put 40 here, okay? And friction is going to push back at 40. And we may be thinking, wow, damn, this friction's pretty strong. I mean, it's been opposing me the whole time. I've been incrementing the whole time at 40. Now it pushes back at 40. You know, when is it going to stop? Well, we've actually reached a max point here. This represents a point of maximum static friction that it can push back against you. Okay, so that's the force of friction static maximum. Okay, and that's going to be mu, okay, which is the coefficient of friction. In this case, it's static friction times the normal. That's the maximum amount that friction can push back at you. But that's not necessarily the amount that's been pushing back the whole time, right? That's the max. Okay, so when I get down here, okay, I need to recognize that fact. I'm going to draw it down here in green. My force applied is 40 now, okay? Now my force of friction is 40, and that represents something completely different now. Now I'm dealing with mu static times the normal. That's the maximum that the static friction, the maximum that it can push back on me. If I go beyond that, okay, let's say I go beyond that to 50 newtons here, okay? So I decide I'm going to push. I'm at 40 and I says, that's it. I'm going to push 50 now. Let's see what friction can do. Now, I'm going to change the color here just so we can clarify this. I'm going to make this red because we're going to be moving. And red is the color of action. So here's now I'm going to push on this at 50. So I'm going to be like, okay, I've had enough. You push back on me, 40, 40. That's it. I'm going to push 50 now. Okay, let me use red. I'm going to use 50. So what are you going to push back on me now? Well, now there's a big difference. Now friction's only going to push back on you at 20. So now what's happening is it's moving. This is the kinetic friction, and you increase the force, but the force of friction that opposes you actually went down. In other words, it's not even what it was at the maximum here. It's actually less. And no matter what you do at this point, it's going to stay at that lower rate the whole time. So that's going to be your force of friction kinetic. It's always the same, mu kinetic times the normal. That's always going to be the same no matter what you do. It's always going to oppose you at 20. So so there's two things changing here. It drops and it's constant now. No matter what you do, it's never going to oppose you more than a certain rate. It basically, it's like capitulation. I mean, if you can think of it that way. I mean, it's basically, it's opposing you, but it's not going to increase as you increase anymore. Okay? So that's this situation down here. So let's just say that I had 50 newtons here, force applied 50. Okay? And now my force of friction is only capable of putting back 20 newtons like that, right? So now I've got a whole new situation going on here, right? Now I have a net force. It's completely different now. Before it was just like a statics first law equilibrium. Now I actually have a net force. So I have a net force now of 30 newtons, right? Because that's a second law application. I'm saying the sum of the forces here, okay, equals F net here. Okay? And that is the situation. I have a net force now. I have an acceleration. It's getting faster and faster and faster, right? So that's what's happening here. I have a linear acceleration. It's getting faster and faster now. Okay? Because I've broken free. Now there is a case where you could be dragging it and slow that force down so it equals kinetic friction. You could drag something at a constant velocity. But in the example I've given you here, clearly you've broken away and you're accelerating faster and faster and faster. Okay, that's clear to see. So I just want to just summarize again the three situations that we have here. Okay, so the first one, again, on this blue line here is situation number one. Okay, so situation number one is here. So situation number one is the following. Friction basically matches you. Okay, and that's basically, think about it like it's bluffing, it's bluffing, it's bluffing, and then it's going to get going. Okay. Number two, friction matches you, but it's maxed out. Okay, and that's when you get the force of static friction equals mu times the normal. And then the third situation is simply that you have motion or kinetic friction. You have motion, and friction still opposes you at a constant force, but it can't match you. Okay, so this is the point where you have won. You are accelerating faster and faster here. Now, the only way to find out situation number one is to do a free body diagram. The force of friction is going to be whatever the force applied. It's going to be equal and opposite. It's an equilibrium problem. The only way to find situation number two is to use this equation, which is the force of friction static maximum is mu static times the normal. And then situation number three is basically you're moving and your force here applied is greater than the force of friction opposing you, and you're going to have a net acceleration if that's the case. Alright, so I hope you enjoyed this video on friction, and just remember, friction will match your force until it can't. Thanks for watching.